Compression tests are often done to monitor the condition of a car's engine, along with the valves and other internal components. If your car isn't running as well as it should, the test can indicate that one of the components has begun to wear out. Performing the test doesn't require much mechanical experience and can be done at home with a compression gauge. If you get an unusual readout from one of the engine cylinders, then you know where to look for problem. Bring the engine to its normal running temperature. If you haven't driven the car lately, the engine will be cold. Start your vehicle as usual and keep the engine running for 5 to 10 minutes. Be careful not to overheat the engine by letting it run too long before the test. You will be able to feel the heat radiating from the engine when you go near it. Switch off the engine before opening the hood. Make sure it is all the way off without any electricity or fuel flowing to the engine. Remove the key from the ignition to ensure the components can be safely removed from the engine bay. If your car plugs into a wall, unplug the charging cable first before handling any components. Put on insulated gloves and safety glasses for protection. Since you're going to be near hot parts, wear heat-resistant gloves while reaching into the engine compartment. Always wear gloves to protect yourself from burns. The safety glasses are good protection against possible gas and oil spray when you're detaching engine components. Remove the fuel pump or injection fuse in your vehicle. Locate the fuse box, which is usually inside the engine compartment. Open the black case to expose the colorful plastic tops of the fuses plugged into various slots. The fuel pump fuses are often colored blue, although this can vary depending on your vehicle. Once you find the one you need, pull it out with a pair of tweezers to prevent gas from flowing to the engine during the compression test. Fuse in the fuse box. This will disable the ignition system so it can't send a spark of electricity to the engine's spark plugs. Use your owner's manual or fuse box diagram to locate it and remove it. Keep it separate from the fuel fuses so you know which one goes where after the test. From each spark plug on the engine, check the engine for a series of black cables coming out the top end. Grasp each wire at the end, then twist it while simultaneously pulling it up to detach it from the engine block. The opposite end of each wire will still be plugged in, so you won't be able to take them out of the vehicle. Instead, push them aside so they are off the engine. Remove the spark plugs with a socket wrench. To make the removal process as easy as possible, fit the wrench with an extension handle and a spark plug socket. Fit the socket into the engine holes uncovered by the wires you removed. Once the wrench is onto the spark plug inside, turn it counterclockwise until you are able to lift it out of the engine. Each cylinder will have a spark plug for you to remove. Put the compression test adapter into the engine's first cylinder. Look down on the engine to figure out which cylinder is closest to the front of the engine. Note the circular cylinders in the timing belt on the engine's front. The first cylinder is on the rightmost ones in most engines. Once you have it, put the test compressor's hose into the spark plug slot, turning it clockwise by hand until it locks in place. You're testing a diesel engine. Make sure you're using a gauge designed for diesel since it will have a higher compression tolerance. Then, check the end of the gauge for a metal connector that fits on the end of the hose adapter. Your gauge may also have a ring on it that needs to be lifted as you fit it on the hose. Otherwise, it's as simple as plugging one into the other. Crank the engine at least 4 times to complete the test. Turn the key as far as it will go in the ignition, then release it. Do this about 4 or 5 times without shutting off the vehicle at all. The engine will be running throughout the entire process. When you're done, check the compression gauge to get the test result. Move the compression gauge to repeat the test on the other cylinders. Unscrew the hose adapter by hand, then move it onto the second cylinder. Keep doing it until you have a result for all of the engine's cylinders. Be sure to record each number on a piece of paper so you can compare them when you're done. Note pressure readouts between 125 and 175 on a standard engine. Most engine cylinders fall in the middle of that range, usually around 125. However, the exact rating could vary due to a lot of factors, like the vehicle you have, the type of engine you're testing, and its overall condition. If you see a result that looks out of the ordinary, figure out what engine cylinder it corresponds to. Make sure the test results are no more than 10% apart. The difference between the highest and lowest cylinder rating should be no more than 15 to 20 pounds per square inch. Big pressure differences are a sure sign of engine problems. Note which cylinder has the low rating to uncover the source of the problem. You may also see multiple cylinders with low readings, which could alert you to more serious issues. A series of low readings could indicate that the valves between cylinders have worn out. It could also be a sign of overall engine failure. Retest cylinders below 100 pounds per square inch after adding engine oil to them. Pour about 1 teaspoon of fresh engine oil directly into the open cylinder. Then, hook the pressure gauge and hose adapter to it again. Repeat the test by turning over the ignition a few times. When you're done, check the readout again to see how it has changed. The pounds per square inch typically rises when you do a wet test instead of a dry one. The change can help you determine what is wrong with the cylinder. If the test worked, a large change could mean the piston rings have worn out. If the low reading is from a single cylinder, check it for worn out piston rings. If the test results were both the same, the cylinder could have a bad valve. If you notice 2 nearby pistons with low C readings, you most likely have a blown head gasket to replace. The gasket is between the 2 cylinders. Low compression in all cylinders could mean your engine needs a new timing belt. If that doesn't work, the engine may need a tune-up. If the engine no longer runs very well, you may be better off replacing it with a new one. Fixing an engine can be expensive, so sometimes getting a new engine from a scrapyard is more cost-effective. Thanks for watching.